In the last lecture, we have seen how to write a basic assembly language program for addition of two numbers, right? So in this program, we have moved the first number to R1, second number to R2. Then in this statement, you are adding the contents of R1 and R2. Result will be stored back to R0. So let us debug this program once again and see. So this is a program. So for executing the program, you can click on the step window. So first line has been executed, 1 has been moved to R1. When you are executing second line, 2 has been moved to R2. When you are executing third line, the addition of 1 and 2 has been taken place and the result has been stored onto R0. Till this we have seen in the last class. So now we will see something known as the status registers present in the CPSR, right? So you have seen that this is the current operating mode of the processor. It is in supervisory mode, and these are the registers available in the current operating mode in the supervisory mode, R0 to R15. In addition to these registers, you can see there is something known as CPSR. So the explanation of the CPSR I have already given in one of my lectures. If you want to have more details about CPSR explanation, you can refer to that. So here you can see all the flags which are required for representing the status of arithmetic and logical operations are present here. First one is known as negative flag, zero flag, carry flag and overflow flag. So these are coming under the category known as condition fields of CPSR. Then the remaining one, that is I, F, these two are used for disabling IRQ and FIQ. Then T for representing thumb state, M for representing the mode of operation. These bits are known as a control field in CPSR. It is used for performing some kind of control operation. So now we are going to see in detail about the condition flags. So here what addition you have performed, you have added 1 and 2 and result you are getting 3, right? So at that time check the carry flag, it is 0, check the overflow flag, it is 0. So all the flags are 0 now, right? Now let us make some small changes in the program, right? So here in this program I have changed my first number as FFFF, that is 8 Fs, right? That is the maximum possible number you can give for a 32-bit data, right? And why I am giving here and shows that the value what I have written in the instruction is of type hexadecimal. So and FFFF means it is equivalent to move R1 comma 0x FFFF, right? So in this statement I will be moving 0x FFFF to R1, 1 to R2, right? Then we will be performing the addition, right? So we will build this program. We are going to debug mode. So you will go to the first statement. When you are executing first statement, what has happened? FFFF 8 Fs has been moved on to R1, that is R1 equal to 0xFF. When you are executing the second line, 1 has been 0001 has been moved on to R2, right? So when you are executing this statement, what you will get? You will be adding FFFF plus 1. When you are adding FFFF plus 1, what you will be getting? When you are adding FFFF plus 1, you will be getting a result as 0. This is a corresponding binary representation. So 1 plus 1 you will be getting 0, again with the carry 1. So all the bits will be zeros. So when you are adding FFFF plus 1, you will be getting 32 zeros. So 0 will be the result of adding FFFF plus 1. But in addition to getting 0 as a result, one carry also will be generated, right? Whenever you are adding 1 to 1, you will be getting a result as 0 with a carry 1. So when you are adding FFFF plus 1, you will be, your actual result will be 0 with a carry 1, right? So how will you identify whether carry has been generated or not? You will be having a carry flag present in CPSR, right? So that carry flag will be set, right? So carry flag set shows that there was a carry when you are performing addition of FFFF plus 1. In addition to that, one more flag will be set. What is that? Since the result of the arithmetic operation what you have performed is 0, since the result is 0, 0 flag also will be set, right? So when you are adding FFFF plus 1, two flags will be set, carry flag and 0 flag. So now we will execute this line and see whether the corresponding flags are being set. So when we are executing this line, so now what should be the result stored in R0? 0. That is correct. You are getting 0 as the final result. Now let us check the flags what you are getting. So for seeing the flag, you can expand the CPSR, right? Actually, you should be able to see that carry flag and overflow flag should be set. But now you can see that both are not set. Why it is like that? Actually, according to addition, FFFF plus 1, you should see that carry flag and 0 flag. Both the carry and 0 flag should be set. But now it is zeros. Why? Why? Because you need to add one more subscript here known as S. I have already told that if you are writing an instruction add R0, R1, R2, your status flags will not be reflected. If you want to update the status flag after any of the arithmetic or logical instruction, you need to add the suffix or add the S to this instruction. S stands for status bit updation. So whenever you need to make a change in the program, what you should do? First of all, you should come out of the debug mode. So whenever you need to change a program, you need to come out of debug mode. How will you come out of debug mode? You need to click on this button again. So you will come out of debug mode, back to the editor area. Here you can edit the program. I am adding S, right? So my actual instruction is add S R0, R1, R2. If you are adding S, then only the status flags will be updated. Otherwise, it won't be updated, right? So now I have made the necessary changes in the program. Whenever you are making a change in the program, don't forget to give build again. Whenever you are changing a program, don't forget to give build again, right? So I am building the program again. So it has been builded, 0 errors. Now again you can go back to debug mode. How will you go back? Click on the start or stop debug section. So now we will execute it line by line. Now FF has been moved to R1, 1 has been moved to R2. Now we will see what the addition has. So now addition has been performed, result is there in R0, right? And you can see that there is a blue color in the CPSR. So whenever there is a blue color, it shows that in the previous execution of the line, there was some modification taken place here. Some of the bits has been updated. Why this blue color is there in R15? Because whenever you are executing an instruction, program counter will point to the next instruction. That means program counter will be automatically incremented. That is why blue color is here. Then why there is blue color in CPSR? You can expand it and see carry flag and 0 flag has been set. So since there was an updation of these two flags, there was blue color in CPSR. So now when you are performing FFFF and 1, when you are adding FFFF and 1, you can see you are getting result as 0 and carry flag and 0 flag has been set. So now we will see when does the overflow flag get set. So for that, let us take, I am moving a value known as 7 FFFF. I am moving 7 FFFF to R1. To that I am going to add 1. So when you are adding 7 FFFF plus 1, what value you will be getting? When you are adding 7FF plus 1, what will be getting? You will be getting R0 as 80000. How you are getting? This is a binary representation. When you are adding 7FF, this is 7, these are FFs, right? 0, 1, 1, 1 means 7 FFFF. When you are adding this to 1, what will be getting? You will be getting 1 0 0 0, except the MSB bit, all the other bits will be 1. Right, so this will be the result. But what change has occurred here now? 0x7FFF means it is a maximum possible positive number that can be represented in ARM. So the last MSB bit represents the sign bit. So if the sign bit is 0, that means it is a positive number. So this is a maximum possible positive number you can give in ARM. Then to that you are adding 1. So what you will get? You will be getting 1 in MSB and all the other bits will be 0. So what is this number? This is a negative number. So 1 in MSB shows that this number is a negative number. That means when you are adding 1 to 7FF, what has taken place? The MSB bit of R1, which shows the sign bit or which is a positive number, 0 shows that it is a positive number. This sign bit has been changed with 1. 0 has been changed to 1. That means positive number has been overflown to a negative number when you are adding 1 to 7FF. When you are adding 7FF with 1, positive maximum possible number has been changed to a negative number. So what will happen? What all flags will be set? First flag will be set, which is known as overflow flag. What does this overflow flag shows that? Overflow flag will be set whenever there is an overflow while you are performing signed arithmetic operation. Right? Now you have performed signed arithmetic operation and overflow has taken place. Why overflow? This was the maximum possible positive number. When you are adding 1 to it, overflow has taken place. And what type of addition you have performed? Signed addition. So signed addition has taken place and overflow has taken place. So what will happen? Overflow flag will be set. Right? Any doubt? In addition to that, one more flag will be set. What is that? Negative flag. Why negative flag? Because whatever result you are getting is a negative number. When you are adding 7FFFF with 0, 1, that is 1, you will be getting 1, 0, 0, 0, 0, and 2 flags will be set. First one is overflow flag, since overflow has performed due to the signed addition, and one more flag will be set. What is that? The negative flag. Why? Because you have received a negative number after your arithmetic operation. So V flag and N flag will be set. So here I am moving 7FFF to R1, 1 to R2, then I am going to add R1 and R2. So now I have again changed the program, again give build, then go to debug. We are executing line by line. So now 7FFF has been moved to R1, 1 has been moved to R2. Now I am going to add these two. So now addition has taken place. What should be the result? 8 0 0 0. That 8 0 0, 7 zeros. So that is present in R0. And let us see the CPSR what you are getting. So here you can see that negative flag is set and overflow flag is also set. So both the negative and overflow flag will be set when you are adding 7FFF plus 1. Now we will see the execution of a arithmetic operation with a shifted register. So I am writing add R0, R1, R1 LSL hash 1. What will be the operation? R0 equal to R1 plus R1 left shifted by 1 unit. So let us take my R1 is 0001. Right? So what will be the operation here? R1 will be added with R1 LSL hash 1. That means R1 will be left shifted by 1 and it will be added with the content of previous R1. Right? So this is a binary representation. So 0001 is present in R1. When you are left shifting R1 by 1, you will be getting 0002. That means this 1 has been moved to the next binary position. So you will be getting 02 instead of 01. Now you are going to add R1 and the shifted value of R1. So 1 and 2 when you are adding you will be getting 3. Right. So now we are going to see this operation in Keil IDE. So now I have updated the program. Move r1 comma hash 1, that means 1 will be moved to r1. Then I am writing add as r0 comma r1 comma r1 lsl hash 1. That means content of r1 will be added with the content of r1 left shifted by 1 unit. Right? Now you will try to build this program. When you are building this program, first you will get an error. We will see that. When you are building this program, you are getting an error. What is that? Missing comma. Which statement? If you want to see which statement the error has occurred, you can double click on this error. So it is showing that there is some error here. What is the error? Missing comma. Where is the comma missing? After R1. Right? So you should see this. It is very important. You should write R0 comma R1 comma R1. Again comma is required. So this comma should be given before the left shift command. So this comma is very important. So now I can give build. So now I got 0 errors. Now I am clicking on this debug. Right. So when I am executing first line, what will happen? 1 will be moved to R1. So 1 is there in R1. Then when I am executing the second line, you should add 1 with the left shifted value of 1. Right. So 1 plus 2, you will get 3 in R0. We will verify that. Now you can see 3 has been placed in R0. So here the addition as well as shifting operation has been performed by using a single instruction itself. That is why in one of our lecture I have told you are having complete control over ALU and shifter. And the shifting operation can only be performed on the second operand. Right, this is my second operand. I can perform the shifting only on the second operand. Right. So in this instruction, first the second operand will be shifted and the shifted value will be added with the first operand. Right. Finally, result will be moved on to R0. So this is how shifting and addition is performed in R. So now let us see how the subtraction program is working. So I have written a basic subtraction program. Move R1 comma 3, that is 3 will be moved to R1, 2 will be moved to R2. Then I am performing sub-bus. Sub-bus means R0 equal to R1 minus R2. Right? How will you subtract? First operand minus second operand. That is R1 minus R2. So I have updated this program. Now I am going to save this program in another name. How will you save this? Click on File, Save As. You need to verify whether you are in the same project folder. My project folder is arm_projt. Right? Here I can give the name of the new program. So I am giving it as sub.s. This .s extension also you should give, because since it is an assembly language program, you give save. Right? So now I have saved the program. Now I am going to build. How will you build? You should click on this build. Right? So now when you are giving build, what will happen? Which program is getting builded? It is not your sub program. You should keep in mind. It is very important. Right? You are now building the project, not the program. And in the project, which program has been added? Add.s. So now again, even though you have written a new program, when you are giving build, your old program present in the project will be builded. Right? So how will you add my new program? You need to add the new program into this. How will you add that? Right click on source group 1, click on add files to group. Right click on source group 1, click on add files to group. Then now you cannot see the S extension program. So how will you make it visible? Click on this files of type. Take this as ASM source file. So now you can see all the S files with the extension .s. So I can add sub.s, give add. Right? So now you can see two programs are there. So when you are giving build, any problem will be there? Problems will not be there. But what will happen? Two programs are there. Both the programs will be having an entry directive. So which program is getting executed? The first program. Right. the entry point in the first program only will be taken. This program will be discarded because this is coming after the end of the first program. Right, again the first program only will be executed. So what you will do? So in the case of assembly language program, whichever program you need to add, only that program should be there in the under the source group 1. You should remove all the other programs. So how will you do that? Right click on this add.s, right click on this, click on remove. So when you are clicking on this remove, you are not deleting the program, you are only removing it from the project. So no problem. You are only removing the program from the project, not deleting. So you can click on this, you can give S. So now you can see that only your subtraction program is there. Now you can build this program. You can give build. Now you can give debug. Right. So when you are executing first line, 3 has been moved to R1, 2 has been moved to R2. You are executing this, you will be getting 3 minus 2. That is 1 will be stored in R0. 3 minus 2, 1 will be stored in R0. You can see you are getting 1 here. And here you can see that there was some updation in CPSR also. What is that? You can expand this and see. Right? But now here you can see that carry flag has been updated to 1. But here when you are performing subtraction, there was no carry. No? 3 minus 2 means 1. There will not be any carry or borrow. In subtraction it is borrow. There is no borrow. But why it is 1? Why the carry flag has been set? Because this also I have explained in one of my previous lecture. While performing subtraction, carry flag, if it is 1, that means borrow is not there. So while performing addition, carry flag equal to 0 means carry is not there. But while performing addition, carry flag is 1 means carry is there. Similarly, if you are performing subtraction, carry flag equal to 0 means borrow is present. Carry flag equal to 1 means borrow is not there. Right? So both the borrow and carry both are shown with the help of carry flag itself. So while performing subtraction, if carry flag is equal to 0, that means borrow is generated while performing subtraction. But now in our case, carry flag is set. So carry flag set means what? There is no borrow. You should keep in mind. So actually borrow is equal to complement of carry. So while you are performing subtraction, carry equal to 1 means what will be the state of borrow? Borrow equal to not of carry. Borrow equal to not of carry means what? Borrow equal to not of carry means, now in my case carry is 1, not of carry means it will be 0. That means borrow is not there. So when carry flag is 1 during subtraction, it represents borrow is not there. If carry flag is 0, that means borrow is there. But now in our case carry flag is 1, so borrow is not there. You should keep it in mind. So in this instruction you are getting carry flag is equal to 1, that means borrow is not there. Right? Now let us change this program. Instead of subtracting 3 minus 2, I am going to subtract 2 minus 3. So how will you do that? One method, I can make this as 2 R2 minus R1. So now R2 minus R1 will be performed. You can build it. Again you can go to debug mode. So now 3 has been moved to R1, 2 has been moved to R2. When you are subtracting, you will be subtracting R2 minus R1, that is 2 minus 3. You can see that. When you are subtracting again, and what will be the result? You will be getting the result as FFF. Why you are getting the result as FFF? Here you are performing 2 minus 3, so you should get the result as negative 1. But instead of getting the result as negative 1, you are getting the result as FFFFF. Why? Because in ARM, negative number is represented by its corresponding 2's complement. When you are subtracting 2 minus 3, you will be getting negative 1 as a result. But in ARM, it will be represented as FFFF. Why? Because whenever you are getting a negative result in ARM, it will be represented by its corresponding 2's complement. So what is the corresponding 2's complement of negative 1? 1, 1, 1, 1. Right, and since your result is shown as negative, because MSB flag is 1, negative flag also will be set. Since MSB is 1, it is a negative number, so negative flag will be set. Then we will see how will we get back the actual number from this 2's complement form. So let us take this is your 2's complemented number. How will you get back the actual number from this? Take 2's complement of this 2's complement. Right, how will you take 2's complement? First take 1's complement. 1's complement of this number means all the 1's will be replaced with the zeros. Then to this 1's complement you are adding 1. So you will be getting 2's complement. So what you are getting? 0, 0, 0, 1. So actually 1, 1, 1, 1 means it is a 2's complement of 1. Right. So whenever you are getting a negative result in ARM, it will be represented by its corresponding 2's complement form. So the 2's complement of negative 1 is this one. So whenever the result is negative, it will be represented in 2's complement form. If you want to get back the actual number from the 2's complement form, what you should do? You should again take 2's complement of this number. So that is why you are getting FFFF here. So FFFF is actually the 2's complement of negative 1. That is your actual result. Then you can expand the CPSR. You can see negative flag is also set. Why negative flag is set? Because my result is all ones. That means MSB is also 1. Whenever MSB is 1, it is represented as a negative number. Right? Since the sign flag is 1, negative flag also is set. Now you have seen an instruction subbus, right? Subbus means R0, R2, R1. What does it mean? R0 equal to R2 minus R1, right? Instead of using subbus, I can use another instruction known as RSB. So RSB stands for reverse subtract. So instead of changing the order of the registers, you can simply change the instruction as RSB and let the order of instruction be the same, right? So RSB R0, R1, R2, what does it mean? You are performing reverse subtract. So operation will be R2 minus R1. In the previous instruction, what I have done? I have written subbus and I have changed the order as R2, R1. So I have changed the order of registers instead of changing the instruction. But the same operation you can perform using RSB, reverse subtract. What does reverse subtract means? Second operand minus first operand will be carried out. So R0, R1, R2, RSB means R2 minus R1 will be done. In normal subtract, first operand minus second operand will be done. That is R1 minus R2. But here R2 minus R1 will be done. We will see whether it is working fine. So first operand has been moved, second operand has been moved. When you are performing RSB, the same result you are getting. That is R2 minus R1 has been performed. 2 minus 3 has been performed and you are getting the result as FFFF.